Alright, this is going to be section 5-7. Before we get started, I wanted to ask you, how many quarters are in $2? Seems like a pretty simple question, right? You could just count them. 1, 2, 3, 4, 5, 6, 7, 8. If you were to write a fraction, you would have $2 in the numerator and 1/4, hence the name quarter, in the denominator. So when you divide by a fraction, you multiply by its reciprocal, which is 2 times 4, or 8. So if I ask you now, how many quarters are $1.50, you would basically write it as 3/2 over 1/4. Remember, by dividing the fractions, you can multiply the top fraction, which is 3 over 2, by the reciprocal of the bottom fraction, which is 4 over 1. So you end up with 6/4. This is what's called a complex fraction, a fraction on top of another fraction in one fraction. And that's what we'll be talking about today. Complex fractions. So what will we be doing? We're going to learn how to simplify complex fractions. And there are two ways to do it. A fraction is a complex fraction if its numerator or denominator, or both, has one or more fractions or powers with negative exponents. Now, as I mentioned, there are two ways to solve these problems. The first method means to simplify the numerator and denominator separately. So what you're going to do is take the fraction on top of the big fraction, take the fractions on top of the big fraction, and combine it into one fraction. Then you will do the same with the denominator. Once you do that, you can divide by multiplying the top fraction by the reciprocal of the bottom fraction. The second way is to multiply the numerator and denominator by the least common denominator of all the fractions appearing in both the numerator and denominator. What you will see is method 2 is probably the better way for longer and more involved problems. I will go through method 1 and method 2 on these slides both, but I'm going to go very quickly through method 1 because to repeat it would take a long time. But you are more than welcome to rewatch it, pause the video, and see what I do. But I would encourage you to pick the method that works best for you. And frankly, I believe method 2 works better and is much easier. Either way, you get the correct answer if you make sure you don't make any silly little mistakes. So again, you have two ways to solve complex fractions, and we'll go through them both. Let's start with example 1. You see the fraction before you. So if we are to use method 1, what you want to do is take the top fraction, 3/4 minus 1/8, convert that to one fraction. Take the bottom fraction, 2 plus 1/12, and convert that to a fraction. And then you're going to multiply the top fraction by the reciprocal of the bottom. So let's see how this works. So we're going to do 3/4 minus 1/8 divided by 2 plus 1/12. So let's do each fraction together. The least common denominator for the top fractions is 8. So you have 6/8 minus 1/8. That's divided by what the least common denominator of the bottom fraction is in twelfths. So 24 over 12 represents 2 and plus 1 over 12. So this simplifies to 5/8 divided by 25/12. Now remember, what you do to divide fractions is you take the first fraction, you multiply by the reciprocal of the second. So let's flip 25/12 around, or 25/12 around, and we get 5/8 times 12 over 25. Now when you multiply fractions, you just multiply across, so you get 60 over 200. Don't forget, you need to reduce the fractions to its simplest form. So both sides, both the top and bottom, are divisible by 20. And you end up with 3 over 10. So again, with the first method, you convert the top fraction to one fraction, the bottom fraction to one fraction, and then you divide them, and then multiply the top fraction by the reciprocal of the bottom. If we were to use method 2, you look for the least common denominator of every fraction in the entire expression. So our denominators are 4, 8, and 12. Well, the least common denominator is going to be 24. So you take your fraction and you multiply everything, top and bottom, by 24. So what happens is you're going to knock out all the denominators, so you have a single number, an integer, both in the numerator and the denominator. So if you do this, the 24 times 3/4 results in 6 times 3, because 24 divided by 4 is 6, minus 3, which is 24 divided by 8 times 1. 24 times 2 is 48. and 24 times 1 over 12 is 2 times 1. So at this point we can simplify this expression. That becomes 15 over 50. We divide the top and bottom by 5, and again we end up with 3 over 10. So again, with example 1, you can do it the second way. The second way, you look for the least common denominator of all the fractions, both in the numerator and denominator, and you multiply the top and bottom by that number. That knocks out all the fractions. If you multiply by number and it doesn't knock out all the denominators, then you need to go back and check to see if you actually use the least common denominator. Negative exponents. If a complex fraction has powers with negative exponents, first rewrite the powers using positive exponents. So this would be the equivalent of saying x to the negative 2 power is equal to 1 over x squared. So rewrite the negative exponents as positive exponents. Example 2, we have the expression you see on the screen. And again, beginning with example 2, I'm going to go quickly through method 1 because it takes a long time to explain. But I'll be happy to go over it with you if you want to know more about it in class, because I think method 2 is actually easier for almost all of these problems. But if you were to use method 1, you would first convert all the negative exponents into fractions with positive exponents. So r to the negative 3 power becomes 1 over r cubed. S to the negative 3 power becomes 1 over s cubed, and so on. So what you end up with is a fraction on the top and a fraction on the bottom. So I'm going to simplify both fractions now, and you're going to end up with this as the least common denominator on the top, and this with the least common denominator on the bottom. You're going to have to do a lot of the math yourself, and I'm just going to quickly go through it. So you see this expression. Now you have two fractions, one on the top, one on the bottom. You're going to have to multiply the top fraction by the reciprocal of the bottom. So let's do that. We have s cubed plus r cubed over r cubed s cubed divided by s plus r over rs. Let's flip the second term upside down, and that's what you're multiplying. You can simplify after you multiply it out, and you see that the s plus r is canceled out. Also, the rs divides into the r cubed s cubed to make it r squared s squared. So our final answer is s squared minus rs plus r squared all over r squared s squared. So again, with method 1, you are going to add all the fractions on the top and the bottom, and then divide by multiplying by the reciprocal of the denominator. Let's take a look at method 2. We have the same thing to start. Now we are going to look for the least common denominator of all four fractions. So what you're going to do is look for the least common denominator of r cubed, s cubed, r, and s. Well, that's going to be r cubed s cubed. So let's multiply both the top and the bottom by r cubed s cubed. And when you multiply the top and the bottom, make sure you don't forget the plus sign, because a common mistake would be to just multiply everything together. Remember, you're distributing the r cubed s cubed into this expression. So you have to multiply r cubed s cubed by every term in the fraction, and the same with the denominator. So when you do that, you end up with s cubed plus r cubed all over r squared s cubed plus r cubed s squared. Remember, you should be able to knock out all the denominators with what you do, because the whole goal is to knock out the denominator. So if you still have a denominator left, go back and check your least common denominator. So we can factor the top as a sum of cubes. We can also factor out an r squared s squared out of the bottom. After we do that, we get an s plus r times s squared minus rs plus r squared all over r squared s squared times s plus r. If we factor out an r squared s squared, this is what we're left with. Well, the s plus r's nicely disappear, and you're left with the same answer you would have gotten in method 1. So with method 2 again, find the least common multiple of all the fractions denominators, multiply the top and bottom by that number. That will knock out all the denominators and leave you with an integer on the top or an expression on the top and the bottom, and then simplify as much as you can. Alright, example 3. I would encourage you to try to do these problems yourself as always, and when you're stuck or you need help or you have the answer, go ahead and resume the video and check your work. Alright, when you're ready, I'm going to go through method 1 very quickly, because I think method 2 is probably the better way to solve these problems, because I think it's less susceptible to mistakes. With method 1, you have a lot more moving parts. So I think method 2 is the easier way, but if you want to do it in method 1, that's fine. So I'm going to go quickly through method 1, then I'll spend more time in method 2. The least common denominator on the top is x squared. and the least common denominator on the bottom is x. So then you combine the fractions into one large fraction on the top and the bottom. And now you have to divide, which is the same as multiplying by the reciprocal. You will notice that stuff begins to cancel out, but you have to factor first. So the x squared plus 3x plus 2 factors into x plus 2, x plus 1. You can see the x plus 2's disappear. One of the x's is canceled on the bottom, and you're left with x plus 1 over x. Now let's go through method 2. The least common denominator of all the fractions on top and bottom is x squared. So what you're going to do is multiply both the top and bottom by x squared. This will knock out all the denominators. So let's distribute the x squared. Remember, don't forget to distribute. So you get x squared. 3 over x times x squared is 3x. 2 over x squared times x squared. The x squares cancel and you're left with 2. On the denominator, you have x squared plus 2x. Now you have to factor the top and bottom to see if you have any common factors that could be canceled out. You get x plus 2 times x plus 1 all over x times x plus 2. The x plus 2's cancel and you're left with the same answer we got in method 1, x plus 1 over x. So you can see how this one just seems cleaner. It all fits nicely on one slide too, and it's less susceptible to mistakes. Number 4. Again, go ahead and try this one yourself. Check your answers if you are finished, and if you are stuck, go ahead and restart the video. But I want you guys to give this a shot. All right, method 1. The common denominator on the top is x squared y squared. On the bottom, it's merely xy. So you end up with that expression. And now you combine the top and the bottom to get that, and you have to divide the fractions. So divide, which is the same as multiplying by the reciprocal. And you can start canceling stuff out after you factor. So we factor the top and the bottom, and we get y minus x times y plus x times xy all over x squared x plus y quantity squared. Well, one of the x plus y's cancels with the y plus x upstairs. The xy upstairs cancels out one of the x's and y's downstairs. So you're left with this answer, y minus x all over xy times x plus y. Now let's go through method 2. And again, I'll spend a little more time on method 2 because I think it's a little easier to do. The least common denominator for all the fractions on the top and bottom is x squared y squared. We have an x squared, a y squared, a y, and an x. So let's multiply everything on top by x squared y squared and everything on the bottom by x squared y squared. Remember to distribute. Do not inadvertently combine expressions. So x squared y squared times 1 over x squared leaves us a y squared. X squared y squared times a negative 1 over y squared leaves us a negative x squared. And again, distribute the x squared y squared on the bottom. So you're left with that expression, y squared minus x squared over x cubed y plus xy cubed plus 2x squared y squared. Let's factor. You can factor out y squared minus x squared as a difference of squares. You can also factor out an xy from the denominator to leave that expression. Now if you've noticed, x squared plus y squared plus 2xy is the same as the perfect square x plus y squared. Usually you see the 2 plus 2xy in between these two. But you can reverse the order or change the order. And so if you factor it further, you get y minus x times y plus x all over xy times x plus y squared. Again, one of the x plus y's gets canceled out, and so your final answer is y minus x over xy times x plus y, the same thing we got in method 1. Alright, let's move to our final example, number 5. You see it above, and again, give it a shot. Just because you have a binomial k minus 2 as a denominator, just treat that as a factor like you would with anything else. And we did a lot of those practice problems in class today, so hopefully that'll give you enough comfortability where you can try this on your own. Alright, again I'm going to go quickly through method 1. Let's convert every fraction on the top and bottom to the least common denominator. The only denominator actually is on the top and bottom is k minus 2. So you have to multiply the k by k minus 2 and divide it by k minus 2 and do the same thing with the 1. If you combine everything, you get k squared minus 2k plus 1 over k minus 2 all over k squared plus k minus 2 all over k minus 2. Now you divide the fractions, and you can multiply by the reciprocal. You see right away that the k minus 2's are going to cancel out. So you're left with k squared minus 2k plus 1 over k squared plus k minus 2. Factor the top and bottom, you get k minus 1 quantity squared all over k plus 2 times k minus 1. One of the k minus 1's gets canceled, and you're left with k minus 1 all over k plus 2. So in this problem, again, the expression has basically one denominator, k minus 2. So you take the k and the 1 and you multiply it by a k minus 2 over k minus 2. Remember, you can always multiply anything by a factor of 1. So a fraction with a common denominator and numerator works very well. Let's go to method 2. Again, we're going to multiply by the least common denominator of both the numerator and denominator of the expression. The only denominator is k minus 2, so we can multiply the top and bottom by k minus 2. And you end up with k squared minus 2k, k times k minus 2 again, you're distributing. K minus 2 times 1 over k minus 2 ends up being just 1. So this is what you have on top. Be careful on the bottom as well, so you make sure you get the right expression. And now we're back at the same place we were in method 1. You factor it, you cancel the k minus 1 that's excessive on the top, and you eliminate it on the bottom, and your final answer is k minus 1 over k plus 2. So, in summary, how do we simplify complex fractions? There are two ways. You can simplify the numerator and denominator separately. In other words, convert them into one fraction both on the top and the bottom, and then divide, which is the equivalent of multiplying by the reciprocal of the denominator of the original fraction. The method below, I think, is the easier and cleaner method. Multiply the numerator and denominator by the least common denominator of all the fractions appearing on both the top and bottom, and that will knock out the denominator, and you're left with basically an expression on top and an expression on bottom. On either case, if you can factor, do it, because you might be able to cancel some of the parts. That ends section 5.7. We will have another example in class that we can do together on Thursday. If you have any questions in the meantime, go ahead and review the video or ask the question on the Facebook page or write it down and ask me in class tomorrow.